We'll demonstrate how to use the sine law to find angles and sides in triangles. And if you take a look at the triangle on the top right-hand side of the page, the sine of angle A divided by its side length, the side opposite it, is equal to the sine of angle B over its opposite side length, which is also equal to the sine of angle C over its opposite length. So the ratio of the sine of any angle to its opposite side is constant for every angle side pair in the triangle. Now, the triangle is often drawn like this when we use sine law, but the sine law actually does apply to right angle triangles as well. We don't bother normally use it if we have a right angle triangle, because then we just use normal sine right angle trigonometry, sine, cos, or tan, but the sine law would apply to those as well. In the example here, on the bottom part of the page, we're asked to find angle A and side C in this triangle. And notice we have an angle and its opposite side pair. You need that information in order to use the sine law to find any unknown angle or side. And so I'm going to find angle A, so I write out my sine law for this. So the sine of angle B over its opposite side, that's the 78 and the 8.4, is equal to the sine of A over its opposite side, we call A. And so substituting in the values for angle B is sine 78 degrees, side B is 8.4, and side A is 5.9 centimeters, and cross multiplying, so the sine of angle A would be 5.9, multiplied by the sine of 78 degrees, which is what's in the numerator here, divided by 8.4. And so we evaluate this, and that will give us what the sine of the angle A is equal to, which is approximately 0.6870. Now make sure your calculator is in degree mode before you evaluate angle A, and we would evaluate to find angle A by taking the inverse sine of 0.6870. And so to the nearest degree, A is about 43 degrees. So in the diagram, we can label A with 43 degrees now. Now we're asked to find side C. In order to find side C, I need to know angle C. In order to find any angle in a triangle, you need its opposite side. In order to find an opposite side, you need the angle opposite as well. So in order to find angle C, I do know two of the three angles in a triangle now. So I can use the fact that all three angles add up to 180 degrees. So angle C would be 180 minus the 78 and the 43. And so angle C is about 59 degrees. So now we can find side C. So writing out my sine law again, and I'm going to use the same angle side pair as I did over here. Sine of B over side B is equal to sine of angle C over side C. And filling in the values, angle B is 78 degrees, side B is 8.4, and we just found that angle C is 59. And so cross multiplying, C is 8.4 times the sine of 59 divided by the sine of 78. And so that makes C work out to be about 7.4 centimeters. So that's the length of side C. Flipping over to the second page, we're given a problem here. We're told that John and Sam are holding ropes that hold a balloon. And so there's the balloon. So here's John's rope. And so we'll call that corner of the triangle J. And we're told that his rope makes a 35-degree angle with the ground. So here's Sam's rope. So we'll call that corner of the triangle S. And I'll call the top B for balloon. And so we'll label the lengths of the ropes that John and Sam are holding, 4 meters and 3.1 meters. And we're asked how far is the distance between them. So we're asked to find this side, which we would call side B in the triangle. Now, in order to find that side, I need to know angle B. And I don't know angle B yet. So I need to find angle S over here. This is a two-step problem. I have to find angle S before I can find angle B and then this side. And so that's why I'm going to find angle S first here. I do know its opposite side, and I know this angle side pair, so I can find angle S. So the sine of angle J over side J would equal the sine of angle S over side S. And so filling in the values, angle J is 35 degrees, side J is 3.1, and side S is 4. And so cross multiplying 4 times the sine of 35 divided by 3.1 is what the sine of angle S would equal. And so the next thing that I would do is evaluate 4 sine 35 over 3.1, which is approximately, to 4 decimal places, 0.7401. Now to find angle S, we take the inverse sine of 0.7401, which works out to be about 48 degrees. So angle S can be labeled in a diagram with 48 degrees. Now, remember, I needed angle B. That's why I found the 48 degree angle here. I need to find angle B. Remember, I have 2 angles now, so I can find the third one by subtracting the 48 and the 35 from 180. And so angle B works out to be about 97 degrees. So we can put a 97 degree angle right here. Now I can use that 97 degree angle in order to find the length of this side, side B, the distance between Sam and John. And so I will use the sine law again. And I'm going to start with the same angle side pair here. So the sine of 35 over 3.1 would equal the sine of 97 over side B. And that's what's written here. And then cross multiplying 3.1 times the sine of 97 degrees divided by the sine of 35 degrees is what B is going to equal. And so we evaluate this and get B to be 5.4 meters. So the distance between Sam and John is 5.4 meters. Now there's a related example on the next page. And what changes here, okay, all the same information, is that this side right here, because of its length, it actually could, the triangle could be drawn differently.